All right, today we are going to work on two learning goals. We're continuing with solving systems of linear equations. So the first thing we want to be able to do is to write our own linear system of equations to model a situation. So we'll do that in example 2. And then the other goal is to solve a linear system using substitution. So this is an algebraic method. The method we learned previously in the last lesson was solving the system by graphing. So the big thing I want you to remember is that the meaning is still the same. Still, the only situations you're going to have are a one solution where the answer is an ordered pair, an infinitely many solution, or a no solution. So that hasn't changed. The solutions still represent the intersection points. So even though we're not actually graphing them this time, if we did graph them, we would still see the same things that we did in the last lesson. So that's really important to remember. So the first thing we're going to do is a prior skills review, because this is a really important skill that we're going to need to be able to apply in one of the steps for this new method that we're learning today. So if 2x plus 3y equals 12 and y equals 2, what is x? So this is what we want to be able to do first. So the key here is that we've been told that y equals 2. And so, because y and 2 are the same thing, this means that we are going to substitute 2 in place of y, or in other words, plug it in. So we are going to plug in 2 in place of the y. So that means that my first step should be 2x plus 3 times 2 equals 12. And this is really the heart of the substitution method, is understanding what it means to substitute. It means to take something that's equivalent and put it in its place. So y and 2 are the same. They're equal, they're equivalent. So I can put 2 in place of the y. All right, so your first task here then is to go ahead and figure out what is x in this situation. So I did the first step for you. You need to simplify and figure out what x is. All right, so our first step should be to do this multiplication here. So 3 times 2 gives me 6. So 2x plus 6 equals 12. We're trying to solve for x, so the next thing that we need to do is subtract the 6 on both sides. So 2x remaining on the left side, 12 minus 6 is 6 on the right side. So then divide both sides by 2. So x equals 6 divided by 2, which is 3. So x should be 3 in this case. Okay, so now that we've reviewed this, again, all we did was illustrate what substituting is. So we substitute the 2, we solve what remains. We're actually going to use substitution, the process, twice when we're solving a system by substitution. So you can see in steps 2 and 3, it has that keyword substitute. So step 1 is to choose one of the equations and isolate. Isolate means get by itself. So we're going to get one of the variables alone. The key hint here is that if one of the variables isn't already alone, you want to look for variables that have a coefficient of 1 or -1. Because that means you're going to have to do less work, and you always want to choose what's going to be less work. Number 1, because it takes you less time, but number 2, because there's less chance for error, less chance of you making a mistake. So then we're going to do 2 different rounds of substitution that's going to allow us to solve for each of the variables. So in step 2, we're going to be able to solve for the first variable. Then, once we have that answer, like let's say we had x equals 3, then I could plug that in and find the other variable. Step 4 is to write the answer as an ordered pair and to check your solution. So remember, we talked about when we did the graphing method that if you take your ordered pair and you plug the x and the y in, you should get a true statement in both of your equations if you've done it correctly. We do have special cases still, as I talked about at the beginning, so we will still end up with some systems that have infinitely many solutions or no solution. When we're not graphing, when we're solving algebraically, the way that this happens is both the variables drop out. So when the variables, both of them, drop out in the solving process, and all you've got left is numbers. So when all you have left is numbers, you're automatically going to either have a true or a false statement. So you might have, 10 equals 10. Well, that's true. Or you might have 0 equals 10, which is obviously false. When the statement is true, that's when it's infinitely many. When the statement is false, that's when it's no solution. Okay, so we're going to do some examples here of solving the linear system. So I'm just going to run through and kind of read the steps as we go. So step 1, choose one of the equations and isolate one of the variables, meaning I'm trying to get x or y alone. Now, when I look at this first equation, x is already alone. So that means I've already got step 1 done for me. So step 1 is done. X is already alone. So then step 2, we're going to substitute the expression that it's equal to. So in this case, y plus 1, we are going to substitute that into the other equation. So this says x equals y plus 1. So that means that x and y plus 1 are equivalent. So this that was by itself, the x, I'm going to take it out of my other equation. I usually just leave a blank parenthesis there. So I take that x out because that's what I solved for here, and I put the equivalent expression in its place. So I have substituted y plus 1 in place of the x. It says, and solve. So I substituted. Now I've got to solve this equation. So there's nothing inside the parentheses that I can do, so that means I can get rid of them. Now on the left side, I have 2y plus y. These are like terms, so that gives me 3y. So I have 3y plus 1 equals 2. If I want to solve for y, first I'm going to subtract 1. So 3y equals, oops, I almost made a big mistake there. This was supposed to be a -2, and I didn't bring down the negative. Whoops-a-daisy. Glad I caught that before we went any further. So -2 minus 1 is -3. So now, to get y alone, divide both sides by 3. -3 divided by 3 is -1. So y is -1. So I'm done with step 2. I solved for that variable. Now step 3, substitute the value from step 2, so that means this guy, into one of the original equations and solve. It does not matter which one. Let's just use the top one. So x equals y, which we now know is -1, so we substitute that, -1 plus 1. So all I did was take the y out, put the -1 in its place. -1 plus 1 is 0. So I have x equals 0, y equals -1. So step 4, write it as an ordered pair. That would be 0, -1. And then I'm going to check it. So I check here. 0 equals -1 plus 1. That's true. So you can even write it up here if you want to check. Check. Then 2y, so 2 times -1 plus x, which is 0, equals -2. So -2 plus 0, yep, sure is -2. So we are confident this is correct. Okay, Now we're going to look at B, and I'm going to switch colors just so these don't all run together here. So step 1, choose one of the equations, isolate one of the variables. Again, step 1 is done. Look, y is already by itself. Don't waste your time trying to solve, one of the other equations. Step 1 is already done there. So that means I'm going to now go to the other equation and take the y out because this is y and this is y. So 12x plus 3 times y. Here's where I substitute. So 4x minus 8. So 3 times that expression now equals negative 24. Again, double check your work each time. All I did was take this second equation. Everything about it should be the same except for the y. I substituted 4x minus 8 in place of my y, and everything else looks the same. So then, now I need to solve. Solving in this case is a little more complicated because I have to distribute here. I've got a number in front of that parenthesis. So distribute my 3 first. So 12x plus 3 times 4 is 12x. 3 times negative 8 is negative 24 equals negative 24. So still not done. I've got 12x plus 12x, that's 24x, minus 24 equals negative 24. Now add 24 to both sides. Those cancel. 24x equals negative 24 plus 24 is 0. This is okay. I always get people that when they get a 0, they think it's one of the special cases. Both my variables didn't drop out. I still have an x here. I can solve for it by dividing by 24. 0 divided by 24 is 0. So x equals 0 again. Trust me, x doesn't always equal 0. So now I'm to step 3. Substitute the value from step 2 into one of the original equations. So I'm going to go back to the top one. Y equals 4 times x, which we now know is 0, so I substitute that, minus 8. 4 times 0 is 0, minus 8 is negative 8. So I get y equals negative 8. So last step, I write it as an ordered pair, and then I check it. So I have negative 8 equals 4 times 0 minus 8. So negative 8 equals negative 8. That's true. So now I check in the second one. 12 times x, which is 0, plus 3 times negative 8 equals negative 24. So 0 plus negative 24 equals negative 24. Also true, so I'm extremely confident. I know that this is going to work. All right, now switch colors again. So I've solved 2. We've done 2 examples. Let's keep rolling. Third one, part C. Solve one of the equations, so isolate one of the variables. Well, this is done in both of them. So again, step 1 is done. So that means now in the other equation, I'm going to put negative 2x minus 7 in place of the y. So here's the y. I'm going to put negative 2x minus 7 in its place. All right, so now I'm going to solve. So add 7 to both sides. Those cancel. I get negative 2x equals negative 5 plus 7 is 2. So divide by negative 2. Those go away. 2 divided by negative 2 is negative 1. So I get x equals negative 1. So now, when you look at this really, you should know what y is because they started out kind of giving that to us. But notice that if you didn't realize that if you just keep following the steps, you're going to get the same answer. So if I now go to this top original equation and plug in the value that I got for x, so negative 2 times negative 1 minus 7, negative 2 times negative 1 is 2, 2 minus 7 is negative 5. So even if you didn't notice this already, you should be able to get the same answer. So plugging into the bottom is easy. Negative 5 equals negative 5. That's definitely true. In the top, we have negative 5 equals negative 2 times negative 1 minus 7, which we know is true. 2 minus 7 is negative 5. So negative 1, negative 5 would be your ordered pair here. All right. Last one in example 1. This is the first time that step 1 is not done for us. So I do not have one of my variables alone already. So here's where this comes into play, this hint. If you want to make your life much easier, you want to look for coefficients of 1 or negative 1. So when I look at my top equation, the coefficient on x is 2. So I don't want to use that unless I have to. I look at the y, the coefficient of y is 1. So this is my winner. So I'm going to get y alone, isolate y. So the original equation, 2x plus y equals 3. If I want y by itself, I need to get rid of this 2x. So minus 2x, minus 2x. Those go away. So then I have y equals negative 2x, and then this 3 is positive, so plus 3. So now step 1 is done. I have y isolated. Step 2, substitute this expression, so the negative 2x plus 3, in place of y in the other equation. So here's where the y was. I'm going to put negative 2x minus 3 in its place. Everything else about this equation should stay the same. So negative 4x minus 2 times, instead of y, I'm putting in negative 2x plus 3. And then that should equal negative 3. So now I need to solve. So I've got some distribution to do here. Bring down the negative 4x. Negative 2 times negative 2x is positive 4x. Negative 2 times positive 3 is negative 6. That equals negative 3. On the left side, negative 4x plus 4x is 0. Those cancel each other out. And so I'm left with negative 6 equals negative 3. Okay, so this is one of my special cases. My variables dropped out. I don't have an x and I don't have a y. So what we need to decide is this remaining statement true or false? And then, based on that, I need to choose, is my answer infinitely many solutions, or is my answer no solution? And remember here, if the statement is true, you're going to say infinitely many solutions. If the statement is false, then you're going to say no solution. So go ahead, look at this statement that we have, negative 6 equals negative 3, and then decide which answer you should choose here. All right, so hopefully you decided that this was a false statement. Negative 6 is not equal to negative 3. And because the remaining statement is false, that means that this has no solution. Now, again, I want you to keep in mind what this means for each of these systems. We solved these with the substitution method. If we were to use the graphing method on them, this solution means that these two lines would intersect at the point 0, -1. These lines would intersect at 0, -8. These lines would intersect at -1, -5. Since this system had no solution, that means that if I graphed these two lines, that they would be parallel lines. No intersection point, no solution. It's really important that we keep that in the forefront of our mind, what the meaning of these answers is. All right, last example, and this is where we need to make sure we meet that first learning goal of being able to write our own system. So, Mr. Wheeler collects old bicycles and tricycles. In his collection, there are 50 wheels and 23 seats. How many bicycles and tricycles does Mr. Wheeler have? So, in this case, we know that there are two different ideas, the wheels and the seats. Now, both a bicycle and a tricycle only have one seat, right? This is not a bicycle built for two, so there's only one seat on each of those, which means that if we let X, and notice what the question is asking, how many bicycles and tricycles does Mr. Wheeler have? We need to make sure we define our variables. If I want to find out how many, that means that's what my variables should stand for. So we're going to let X equal the number of bicycles, and we're going to let Y equal the number of tricycles. So since they only have one seat each, that means the number of bicycles plus the number of tricycles has to equal the number of seats. So in this case, 23. Now, the wheels are a different story because we know that the total number of wheels is 50. But each bicycle has how many wheels? Hopefully you answered 2. So that means however many bicycles you have to multiply that by 2 to get the number of wheels. So 2x. Tricycles have 3 wheels each. So 3y. So hopefully that makes sense. And so what we need to do now is we need to solve this system that we wrote using our substitution method. So I'm going to switch colors again. So we wrote the system here. Now I need to do the steps. Neither of these are solved for the x or the y, so we need to do that ourselves. That's step 1. Remember, choose one of the equations, isolate one of the variables. We're looking for coefficients of 1 or -1. In the bottom equation, x has a coefficient of 2 and y has a coefficient of 3, so we don't want to choose that one. Up here, however, both x and y have a coefficient of 1, so it doesn't matter which one you choose to get alone. So I'm just going to take this equation and I'm going to get x alone this time. It doesn't matter if you choose to get y alone, that's fine too. But in order to get x alone, I would subtract y on both sides. Those cancel out. X equals -y plus 23. That's step 1. Step 2, I now take this expression and I substitute it into the other equation. So here's my x. I'm going to put this -y plus 23 right there. Everything else about this equation stays the same. So 2 times -y plus 23. So that was in place of the x. Now I continue copying the equation. Plus 3y equals 50. So distribute. 2 times negative y is negative 2y. 2 times 23 is 46, plus 3y equals 50. I've got like terms over here, so negative 2y plus 3y is just y. So I've got y plus 46 equals 50. So to get y alone, I've can I scroll down anymore? Nope, I've run out of room. So minus 46, I'll just write it up here, minus 46. So y is by itself. 50 minus 46 is 4. So I get y equals 4. Now I need to substitute that into one of the original equations. It doesn't matter which one, but this one has less in it, so I would use that one. So x plus, in place of y, I put 4 equals 23. Subtract the 4 to get x alone, and that gives me x equals 19. Now, this is going to be an exception because we're not going to write our answer as an ordered pair. The reason being that this is a word problem, we need to answer the question. So how many bicycles and tricycles does Mr. Wheeler have? Well, we said X is the number of bicycles, which is another reason why you really need to write this out, define the variables. So we would say 19 bicycles and 4. There we go. 4 tricycles. And then just check to make sure it makes sense. Seat numbers, 19 plus 4 is 23. That works. Number of wheels, 2 times 19 gives me 38. 4 times 3 is 12. 12 plus 38 does indeed give me those 50 wheels. So I know that this combination works. I checked it, and so I'm good to go. All right, these steps only get easier by practicing them over and over and over. You cannot skip out on the practice and expect to be able to do this well on the assessment. So please do every single practice problem. Reach out if you need some help.